So in terms of like signed integers, basically we use three major representation. One is sign and magnitude representation, one is 1's complement, and one is 2's complement. So here for the description or for the explanation of these three types, we have considered like a 4-bit word is size is taken. Word size means we are going to have a 4-bit data we are going to consider, and 16 different possible data will be there if we are considering the 4-bit type of machine. That means a word is there, any architecture is there that is only supporting 4 bits. So that means the possible range will be between 000 to 1111. So starting with 0 to up to 15. This will be the range of possible numbers. So in this possible numbers, some will be considered as the positive numbers and some will be considered as the negative numbers. So how the positive and negative will be decided, we will just show one by one. So this is the sign and magnitude representation. So we already know like if a number is written like 100 so it is first of all we are considering only 4-bit because we have taken an example of only 4-bit type of data. So in that 4-bit, the 3-bit will be representing the magnitude, and this MSB side will be indicating the sign. Sign means either it is positive or negative number. So once it is written like that, so last will be indicating the sign. So if sign is like if it is 0, it will be considered as the positive number. If the last bit, that is MSB bit, is 1, then it will be considered as the negative number. Okay, and just by seeing the last bit, we can consider whether it is positive number or negative number. And once we know that it is positive or negative, the remaining 3 bits, by separating the sign bit, whatever the bits available is there, that available bits will be indicating its magnitude. So if it is 0 means it is a positive number, and again 000 is there. So 000 is representing the 0. So that's why it is plus 0 or positive 0. Next one is 0 is there. So this 0 indicates the positive number, and these 3 bits 001 indicates the binary 1. Okay, so in decimal it is 1. So 1 is it is plus 1. Similarly, this is 0 is there, so it is a positive number that will be there, and 010 is nothing but a 2. Similarly, if it is 0 110 is there, 110 is equivalent to decimal 6. So plus 6 is there. Similarly, we can consider the 7. We just go through the 8. In the 8, this is 1. 1 means a negative number. Okay, a negative number. So 1 is there, so we will consider a negative. Again, the remaining 3 bits are 000. It is indicating the 0. So minus 0 it is indicating. Similarly, this one is there. So if it is 1, that means it is negative. Next 3 bits are 001. So 001 is nothing but the 1. So it is minus 1. Similarly, consider the next one. If it is 1, that means it is a negative number. Next 3 digits are 101. So 101 is nothing but 4 plus 1 is 5. So minus 5 it is indicating. Okay. Similarly, at the last we can just see this is the 1. That means the negative number. 111 is nothing but the 7. So it is minus 7. So starting with plus 0 to up to plus 7, then minus 0 to minus 7. So the range of numbers represented in terms of sign magnitude representation is from minus 7 to plus 7. This is the range of sign and magnitude representation of numbers. In case of this is for 4-bit representation. In 4-bit representation, the range will be like that. In generalized form, we can just write like the generalized range will be like minus 2 to the power n minus 1. Okay, n minus 1 minus 2 to the power n minus 1 minus 1 2 plus 2 to the power n minus 1 minus 1. So you can just see if you will be putting n equals to 4, it is coming out like 2 to the power 4 minus 1, that is 3. 2 to the power 3 will be 8 minus 1 is 7. So minus 7. Minus 7 2. Again, this is plus 7. So its range will be between plus 7 to minus 7. Its disadvantage is like it is going to represent 0 in two different forms. So here this is also a 0 and this is also a 0, plus 0 and minus 0. So either it is 0 0 0 or it is 1 0 0 0. Both are representing 0. So there is an ambiguity is there. That means it is not confirmed whether we can use this representation or that representation for representing the 0. So this is its disadvantage basically. So we will move to another type of representation that is called 1's complement representation. So suppose 1 0 0 1 is there. So its 1's complement will be we will be complementing each bit. So 0 will be complemented by 1, complemented to 1, 1 will be complemented to 0, 0 will be complemented to 1, 1 will be complemented to 0. So once we are going to complement each bit, then whatever the number is there, this is binary and this is 1's complement. So this is the binary number and its 1's complement will be this one, just complementing each of the bit. Similarly here also, in case of 1's complement representation, always the 0 will be indicating the positive number and 1 will be indicating the negative number. Just take care of it. Okay. So 0 will be positive. MSB is 0. That means a positive number. And if MSB is 1, it will be a negative number. But its magnitude is not like the remaining 3 bits. It's not like sign and magnitude. So in this case, the magnitude will be coming out the whole. So whatever the number is there, that will be considered the whole as the magnitude. So if it is a positive number, whatever its decimal equivalent is there, that directly it will be considered the same. So if it is 0 means it is a positive number, 0 0 0 is there, it will be 0. If it is a 0 means it is a positive number, its decimal equivalent is 1, its decimal equivalent is 2. Similarly, if this is there, its decimal equivalent is 7. So for positive numbers, all the forms are having same representation. But here comes the negative part. So in 1's complement, if this is the negative number, because this is 1, MSB bit is 1, then it will be a negative number. If it is a negative number, then we need to find out its magnitude in negative, like in decimal if you want to find out. So first of all, it is 1 0 0 0. So this indicates the negative number. That means it is surely a negative number minus, but its magnitude will be given by like, because this is a 1's complement representation, we need to convert it into binary representation. To convert it binary representation, we need to take the 1's complement again. It is in 1's complement, again we will be taking 1's complement, then its equivalent will be in binary. So we need to take the 1's complement of 1 0 0 1. So 1 0 0 1, 1's complement will be 1 1 1 and 0. So 1 1 1 1 and 0. So its decimal equivalent we need to find out. So its decimal equivalent is 7. So now the number will be minus 7. That means whatever the negative number is there, we will be identifying with MSB bit. MSB bit is 1, it will be a negative number. But its magnitude will be decided by taking the 1's complement of that number. Its 1's complement we will be taking. So once we have taken the 1's complement, now it is in binary. Now it is in binary form, normal binary. So normal binary to decimal we have written. This decimal equivalent is 7. So now it is minus 7. Similarly, consider this one. This is 1 1 0 0. So 1 1 0 0 is there. So this is MSB is 1. That means surely it is a negative number. But its magnitude will be given by converting this number to 1's complement. So we will be taking 1's complement of this number. So it is 0 will be 1, 0 will be 1, and 1 will be 0, and 1 will be 0. So it is 0 0 1 1. This is in binary. This is in binary. And its decimal equivalent will be like 3. So this is 3. It is decimal equivalent. So now its value is minus 3. Okay. So similarly, we can convert 1 1 1 1. So if it is 1 1 1 1, we will be converting it by taking the 1's complement. It is coming out to be negative of 0. So again in 1's complement also there is two different representation form for 0 is there. So this is the disadvantage of 1's complement also. So to remove the disadvantage of sign magnitude and 1's complement representation, there is another type of representation called 2's complement. So basically in 2's complement, we have a single representation for 0, and also we need to find out the range. Like in 1's complement, what is the range? So in case of range, we can just see like it is +7 to -7. Again here, -7 to +7 is the range in case of 1's complement also. So in terms of the general form, we can write like -2 to the power n minus 1 minus 1, 2 plus 2 to the power n minus 1 minus 1. So this is the general form 1's complement range. So in 1's complement, the range of numbers for n bits will be generalized form is this one. In case of 2's complement, we can just see it is ranging between +7 to -8. This is the advantage. And also here, because we are just having one representation for 0. So 0, 0, 0, 0 is having the one representation 0. This is +0. There is no -0 in 2's complement. That's why for every operation 2's complement is preferred. Instead of other complement representation, 2's complement is preferred because it is having one representation of 0, and also its circuit complexity is less. Its circuit is less complex, you can call it. Oh, okay, or less number of transistors basically required to implement this 1's complement. So similar to that, for positive numbers, these are the positive numbers. For positive numbers, either sign magnitude or 1's complement or 2's complement, all are having the same representation. But in negative case, the MSB bits will be indicating the negative number. So if it is 1, 0, 0, 1, so this indicates the negative number. That means it is a negative number. But its magnitude will be given by, because this is a 2's complement number. 2's complement. So again, we will be taking the 2's complement to convert it into binary form. So to take the 2's complement, what is the method? Whatever the from the right side, whatever the first one will be coming, we will be putting at as it is, and all other bits will be complemented. All other bits will be complemented means 0, 0 will be considered as 1, 1, and this is 1 means it is converted to 0. Now this is in binary, and its equivalent in decimal is 7. So now this 1002 that is written in 2's complement is equivalent to -7. Similarly, consider another example like this one. So it is 1110. So this negative indicate a negative number, but its magnitude will be given by, because it is 2's complement. Again, we need to take 2's complement. So once we will be taking the 2's complement, the result will be in binary. So it is from right side, we need to consider wait for 1. So 1 comes here. So when 1 comes, till that we have to put as it is. So 0 and 1 will be as it is. After that, whatever the numbers are there, we need to complement. So it is 1, 1. So we need to complement, it is 0, 0. So after it is in binary, in decimal equivalent, it is 2 in decimal. So its representation will be minus in decimal. So this is how we can represent the numbers. Okay. So this is all about the basic complement numbers. The summary you can just see, like if a binary number is there, so this is a binary number. For positive numbers, you can just see, for positive numbers all have the same representation, but for negative numbers we have the different representation in case of 1's complement, 2's complement, and all other representation, and that will be depending on the previous cases we have seen. Okay, so in case of here 2's complement, the range would be like, so instead of here the range will be, range is important. Okay, in Viva type questions, range is basically asked, so take care of their range in case of 2's complement. So here it is going to have, instead of -7, it is plus -8 is there. So it is like -8 to +7. So the generalized form we can write like -2 to the power n minus 1, -1 will not be there, 2 plus 2 to the power n minus 1 minus 1. So this will be the range in case of 2's complement. So I hope you have got the point.